start our lecture. So first hour, I will talk about how to do the PPT file for your final project. And the second hour and third hour, we'll continue to talk about Faster RCNN and the Mask RCNN. And next week, the first hour we'll have the exam. The second exam for the first hour next week. And the exam, the question is the same, similar to the midterm, the first exam. Okay, very similar. Just most important one is the physical meaning. And we'll cover from after the first exam. Okay, before first exam we don't include the content for the second exam. So for the second exam, the content will be from after the first exam until today. So that's for the second exam. So our assignment, we have two assignment. We almost done. So each one is 20%. And then final exam, we have two exams. So each one the same is 20%. And for the final project is at the week 18. That is for our final project. And next week, remember, next week, the first hour is the exam. And the second hour and third hour, I will teach you about GPT. I will teach GPT next week. I already put the lecture on the FTP site. I think the FTP site, this morning I just checked some problems. I cannot visit the FTP site. So the TA will check it for us. Thank you. Okay, so I will continue this one. So for our final exam, the important thing is the PPT file. So you will give for the week 18. Okay, each group will be go to the classroom, and then you need to do the presentation. Okay, so they will take 40%, and then the PPT you need to present using the PPT file. So today I will teach you. Right now I'll teach you how to do the PPT file. It's better you can have a demo video. Okay. And then finally you need to upload the source code. So you can upload the PPT file, the demo video, and source code. Now, when it will be the deadline for uploading, the TA will tell you on the Moodle. And it should be like to the day of week 18 or after that one, after that day. We will let you know. So for the project presentation, is during the class time. So the same as today. And all the group members should be here. And please bring your notebook for the presentation. And for the PPT file, it's around just suggest it's around 20 to 30 pages. Okay, and then you need to have additional the video demonstration. And the content for the paper you report, I'll teach you right now. But for the source code, it's fine if you directly download the source code from the paper website. That's fine. And you compile it and run its data. That's all okay. Or if you have your own work, okay, actually that's better. but that won't affect your score. So don't worry. That won't affect your grade. So don't worry about that one. Okay, so suppose we have a paper. So suppose we have a paper, and the file name, your file name can be like, let's give you. This can be your file, the file name that you write which group you are belong to. So like a group, the number 6 group. So the group all 6 and file name. Okay, and this is the paper they publish, and the day you present, and the version and the beta. It's just for example. So suppose we find this paper. We find this paper, and this paper, the publication is from IEEE Signal Processing Data in year 2016, for example, and it's the name of author and this title. The title is about the face detection and alignment using multitask cascading convolution neural network. This is a good paper. All right. So in your PPT, okay, the beginning you write this one, your title, the name of the authors, okay, and then the publication year 2016. And here, important one is that please write down which group you are, because I will check this one. After you upload the PPT file, I will check the PPT file for each of your group. Okay, and write down which department or institute you are from. And if you have a laboratory, just write your lab and your name here. Okay, so that's the first page. And the second page is fine. Don't worry about it. So what I try to tell you is that this is just for example, but usually because we are engineering, so we usually do this way. First of all, we will do introduction, include motivation, objective, global framework. Okay, and if your paper or your work has system, you should write system setup like we do robot arm. So robot arm, where is the camera? Where is the robot arm? Where is the table? Something like that. And framework is the algorithm. This is the algorithm usually. So this will be so in the actually the most important one is the chapter 3, the algorithm. And then you should list what kind of data you have and what's the experimental results. So important one is this chapter 3 and chapter 4. So for the introduction, the first one you should write the motivation. Motivation meaning what? Because in this case, they do face detection and do the alignment. Alignment meaning you have a feature point here. You detect the face, also detect the landmark, or we call feature points on the face. So first of all is why people want to do this research, we call motivation. So motivation is kind of application. Why you want to do this research? Why you want to develop the algorithm? So what's the application? So that's motivation. So usually in the paper, or this paper, the motivation is here. The first one, introduction. So in the first one or second sentence, usually the paper will tell you what is the motivation. So like here, they say, okay, the motivation here is that we have many face application. So motivation, we want to do face recognition. We want to do facial expression analysis. That's the motivation. So you just try to copy it up. So the first paragraph of the introduction usually is a motivation. The same as the abstract. The abstract first one or two sentence is the motivation. Okay. So after motivation, so what is the major purpose for this paper? We call objective. So this paper, they will directly tell you, we will detect the face. We will do the landmark detection. So that's a very simple, that's a very straightforward. So that's a objective. Okay. So this is motivation objective. So after this one, the third one, the very important is that you should give people an idea. Use the graph. So this we call global framework. So you should draw a global framework. So global framework, usually the important thing is block. Like this one. Here. Block. So what's the input? And what's the first block? First block usually. The first block usually the data collection, the input. The second block, third block, usually are your algorithm, your network, and finally is the output. But in this case, the global framework is meaning you just simply give people an idea. So the important thing is the image and the title, image and title. Okay. So for example here, we will see they have a suppose test image and they do the pyramid. And then this input, so they do resize. I should say input here. And then after they input a network, so the first network they call PNet. The second network called RNet. The third network called ONet. Usually most of the paper just one network. So just one network is fine. And finally is output. The output will be here. So your input is this one. And this is your second block algorithm, and your output will be here. And between the images, this one. So you will directly tell people, okay, for the first one is a NPNet, but in global framework, you don't need to write the architecture of the network. In global framework, usually we don't write the architecture of the network. We just write, okay, we have a like example, input here and output here. And this method is that we call PNet. And this is first. What's the physical meaning for the first step? So this one, we want to be first to detect the candidate of the face. And after we have a candidate of the bounding box, we go to the next step. And next step, the purpose is try to do refinement of bounding box. That's meaning most of the candidates we will delete it using what kind of method? The method is RNet. So finally, we have this one. And after the output here, and the last step is that we want to make sure the accuracy is good. So we have only one detection result, and then use ONet, we can detect the landmark of the face. So 3 steps, and we write it here. Sorry, I say again, important thing for global framework is image, and then input, output, and using what kind of method, and what's the purpose. Don't need to tell the detail about the network or architecture. Just give the people an idea about global framework. So in the paper, usually the global framework, sometimes in the introduction, sometimes just after the introduction, just briefly giving people an idea. Okay, so we will understand what the paper for, what's the contribution for the paper. So talk about contributions following. So after we have a global framework, and 1.2 is what is the related work of this motivation? Because we have a motivation, why people want to do face detection alignment, and then what the people, their method. So their method is here, it's called related work. So usually the related work is after the introduction, but after the second paragraph. So second paragraph, they say, first of all, they say, okay, for the face detection, we have many papers talk about that one. So that's the second one. And then for the face alignment, we have a different kind of a paper here. So that's a related work. So related work usually, sorry, is 1.2. And then you are listed here. What kind of method? For example, they have detection, they have alignment, or for detection, they have what kind of method. So what this existed paper, people already talk about this topic. And what's their advantage? And what is their disadvantage for those papers? But in this class, you don't need to write related work. Okay. I don't give you the difficulties. Just you don't worry about that one. I just let you know. So you can ignore this one for your PPT report. But I just give you an idea. Usually, we should write for you, like especially for your paper, for your thesis. You need to, because you already study a lot of papers. So you need to write what's the advantage. It's the advantage, but it's not one paper for each. No, you should organize topic. So this method, suppose have 5 papers talk about use this similar method, and what's the advantage for those 5 papers and disadvantage. Or the other 6 papers, the other method talk about that one. So that's you need to do the organization for this one. So after in this PPT, if I write example here, it's meaning this one doesn't exist in the paper. I just give an example, but paper did not tell you the detail about this one. Actually, I did not go through the details. So this is I modify from my students' PPT report. So I just give you a reference. Okay, the finally is what's your contribution? Okay. Because you have a idea, motivation, objective, you have a global framework, you also find the problems of the people, the people their work. So finally, the paper was say, okay, so my contribution is this one. So the contribution usually is at the last paragraph of the introduction. This introduction and the last paragraph here. They will say, oh, we propose some kind of method, and so our contribution is this one. We have 3 contributions in this paper. So when you study a paper, usually it's this kind of rules. this for engineering work. I don't know other fields, but in engineering, almost 80% the paper is like this kind of a organization. So, okay, so the last paragraph of the introduction is their contribution here. So they say that we propose or we develop what kind of method, and the method is try to solve. See, so the method here actually will be similar to this one. So you organize the related work, and this organization, the itemize the method, usually the method will corresponding to your contribution. So that's meaning, okay, the first method, the same as other people. So you organize five person, their paper using this method, but you find their problems. So this one is you try to solve these problems. Okay. This one, so it's Q&A. So we do a research. It's always, I train my student, train you guys is training how do you find the question, is Q. How can you solve those questions? That's the answer. So the Q is here for the existed papers. The answer we try to solve here. So that's our contribution. So for the introduction here, when we read the introduction, we will understand the important ones. You will understand what's your method. Your method is a global framework, and your contribution give people idea what kind of a problem you solve. So when I'm a reviewer, I check the paper. It's very easy. When paper come in, we just check the first one. What's the application? Okay, and we just briefly check the related work and whether the related, because we are expert, so we'll find whether the important paper they include, and then I will find a contribution. But first, what's the contribution? Everything is that correct? And then we'll find the first or second graph, because usually the first one or the second figures are there for both framework. Is that clear? If it's not clear, probably will think about I will try to reject this paper. So when you submit a paper or you do presentation, okay, for the first 5 minutes, we'll decide. We'll give an idea. I have an idea whether we'll reject your work. When I was in Carnegie Mellon, as I remember, we have one assistant professor from the other European school. It's a very good school. They come here. She do a presentation about robots. And we are PhD students. We come here and then try to understand what's her work. In the first 5 minutes, she did not present well. So half a student left. And she continued to talk. Doesn't look good. So about the first 6 or 7 minutes, all the students are done, except me and the professor. He invited her to give a talk. And then the professor said, okay, don't talk. And he said, why you are here? Ask me. Because I'm only one Asian student. Other are the American students, mostly. So they feel, oh, that's not good, they just left. You know, he say, why you are here? Because I'm the new student. I dare for not to leave. 我不敢离开，因为我们的教育是不能离，常要尊重别人嘛。然后呢 ，so the professor said, no, you should go. This talk is not good. 这美国人很直接哦，当着那个教授面前跟讲，那个讲得很不好，应该是 我们那边是全美第1名的学校，第1名的那个罗巴茨，他讲得很不好，就直接就离开了。所以那个很现实的，很现实那种。所以美国是一个高竞争的地方哦，一样学生也是一样哦。我们每年都要被评估，我们读书是每学期，对不起，每学期都要被评估。教授直接讲了，你要留校才看，要是准备离开了。所以我们不多了，因为大家都很拼，大家都很拼。那第1年都不行，就直接淘汰掉了。你后面还有很多人，所以那是高竞争的社会。所以我说高竞争社会是不怕没有你，反正你不行就淘汰，后面还一堆优秀的，全世界优秀的人要进来，所以那边淘汰就不行就淘汰这样子。那淘汰的理由有时候不是你不，有时候不是你功课哦。我被警告过一次，吓死了。理由是英文不好。你是美国啊，你这是美国，英文怎么可以不好？对不对？啊，所以被警告说你英文。我还有另外一个陈银安，我另外一个他是另外一个在做那个，他很强，让他做叫什么 head 的，那时候他有回成他蛮好。我毕业，我跟他同，他是另外一个实验室的，是 computer science。那时候台湾学生能够进入 School of Computer Science 不多，那他还是很强，然后他很爱国。那我们两个大概同个时间，1998年毕业，然后他就说哇，我要回台湾贡献，所以他去交大，他回交大教授。因为他 Q 学生，我们出去薪水都很高嘛，然后说就去我比较喜欢去业界，因为我们美国大概70%的博士都去业界，所以我就去业界工作，去业界那边工作，然后他就回来。那回来的时候，他2年后就回美国了，因为他回来他不适应台湾的环境的，他觉得学生不够积极，然后老师大家不合作，就两个完全不同的。我们现在从这里做教育，可是我们在美国受博士教育，那都是我们都是 teamwork 独立研究嘛。你要独立研究能力，要 teamwork 能力。然后教授也在教，是以学生为主，所以一个学生，你一个学生可以找很多老师来共同指导，是以学生为主，我们是以老师为主。像我有3个指导，共同主要的指导，还有2个那跨领域嘛，我们都做跨领域。所以他2年后他就回去美国赚大钱，然后跟我讲哦，我受不了，受不了台湾的，我说你不要这样子啊，你看那时候他很爱国，然后很失望的回美国，如果现在不跟，因为我们那时候只有 email，也没有像你们现在就失去联络了，很好一个朋友，很多朋友都失去联络了这样子，啊环境影响。OK，那我说那是一个美国是一个高度竞争的社会啊，比我们比起来啊，就像你不要以为日本人都知道台湾没有，我遇到日本人都不知道不知道台，我现在不晓得了，那个时代，包括我老板是日本裔的，说我也不知道台湾是什么，没听过，没兴趣。他最近有来吗？对那种小国家他没兴趣，他只知道台湾是个算比较进步的国家，那进步的国家就是属于台湾可能是日本的一部分这样子，因为亚洲只有日本是进步国家嘛，那那时候其他落后国家嘛，那我们是属于进步，所以他以为，台湾是属于日本的一部分，因为以前历史是这样，啊，其他都大陆那些落后国家，所以他们对这些也没兴趣。这个是一个，就是他们那个社会很自由，就是像我是外国人，他们有些外国人是这样，我们有时候看到外国人可能对他有兴趣，他遇到美国人没有，他是也不是每个极端，有人有兴趣，我真的对亚洲人有兴趣，尤其对亚洲女孩子很有兴趣的是一堆，然后有些人是白人，根本对黄种人一点兴趣都没有，只要有色人种，他根本都不想跟你谈话这样子，所以各式各样的人都有。好，we back to here. By school, Taiwan, we are a nice people, friendly country. Okay, so the second one, I continue. So that's the first chapter. And the second chapter is what's your system? Like I said, just say that robot arm, where is it? You put a camera, so system setup. But if you have a system setup, you write it. If you don't have it, you don't need to write it. And for the system, usually like as I said, suppose we have a robot arm, we have camera, so this one probably paper does not describe the detail about like the real sense. So you need to find the information from the internet. So there's a real sense, and they have a spec here. Spec resolution and frame rate and accuracy. The important one is if you can find some more detailed performance like this one, this x-axis for the real sense. This x-axis is the distance. So from 0 to 500 millimeter, 1000 millimeter. So let's tell you the real sense, the distance that they can allow to detect the object up to 4,000 millimeter. 4公尺. So actually this one is not good. And what's the depth error? That's meaning, for example, if it's this 10 millimeter, the 1 central meter or 10 millimeter, see up to 150 millimeter, this is okay, the error. But after 150, I should say 1500 millimeter, the depth error become large, getting large. So this is a good one. It can provide this information. So we have the system setup, we have the hardware specification and the function. And that's it for the second chapter. So the third chapter is your major framework. Okay, so this should be more detail about this one, more detail about global framework. So we'll write the details, especially we are doing the deep learning. So we need to write the network. And this one we call architecture. So the input and the convolution 3 by 3. Okay, and suppose input image size is 12 by 12 by 3 channel, and they do downsampling, maximum pooling. They use 3 by 3. Usually 2 by 2, but they use 3 by 3 maximum pooling, and the image size become 5 by 5 by 10 channel, so getting smaller. And finally, the last step, they have a phase classification, they have a boundary, they have a landmark. Just for example. Okay, so this one is fast because we don't need a high accuracy in the first step. They design this one. So they roughly detect it and then refine it. And finally, they got a better result here. So you can see the resolution here is low resolution. It's higher resolution, much higher resolution. So the low resolution quickly delete, not face. So it's 12 by 12. And the final resolution is 48 by 48. It's higher resolution because they want to detect the landmark. Okay, so low resolution can be, the parameter is less parameters, so the speed will be fast. So we can consider this kind of a stage for the process, but very simple, almost the same, almost the same, except the input resolution difference. Okay, so that's the idea. And this paper, we did it, and the result is pretty good. Okay, so that's for training and the same as the paper. So for the paper, after the first chapter and the second chapter is here. So the second chapter, either systems app, but in this case, they don't have a system, for example. So they do the method, and here they call, sometimes they call method, sometimes they call different kind of a name, but the same, this is details. So first of all, they say, okay, right now, I tell you what's our global or overall framework. This one, figure 1, see? So give people an idea. So figure 1 is this one. So it's important, the first one, you should give people an idea. As I said, in the other way to say, if you want to judge a paper is good or not good, you can do as the way I did. Just check it in briefly. The motivation, what's the motivation? What's the contribution? And then go to the method, say, what's their framework? So just check it. So that for each paper, the important parts are figures, tables, equations. Okay, so if I check the paper, whether it's good or not, I check it. First of all, I check the title, and I check the author, whether the author is famous in this field or not, the author. Okay, and then I check the introduction, the first paragraph, and check the last paragraph, and then check the figures. The figure is not good, usually that's not good paper. And the figures, we call captions. Caption is very important. 这个字很重要。通常好 good paper, they will write this important. They will describe briefly what is this one. Okay, so I check the figures and I check the equation, because equation is how people write a code. You write a code, you do the programming, you write a code. It's based on the equations. So equation is important. Okay, but in the other way, if you find the equation are so difficult to understand, probably this paper you don't understand. Sometimes they have many equations, and you find most of the equations you don't understand. Probably you don't need to study this paper because you don't understand this paper. Okay. So we do the figures, see? So the detail, I say again, this global framework, this is detailed framework and equations. So those are equations. You check the equations. So just follow the order, check the equations, and then check the figures, the result, and the table. The table, usually we don't check it very detailed. We just check it like this one to just check whether their comparison is good or not. And then we got to see table. What I check is their method is this one. Others are this one. Check whether the result is good or not good. And that's it. That's the first step. We will check whether this paper is good or not good, whether we will decide to study or not study. Okay. So I go back. So for the detailed framework, so overall framework, so continue here. So we'll the same. You'll do this one. So the system framework is important. And after the detailed framework and 3.1.1 usually is training framework, more details. But this kind of a framework, usually you need to write by yourself, because the paper don't tell that those kind of statement is in the content, not in the figures。就这里的这些 detail 通常在文字里面叙述，它在这里看不到。这些东西会在文字里面叙述，所以你要把文字里面叙述把它呈现出来。这 detail。So usually like this one. So we explain the details about this framework. So we and 3.1.1 is training framework. So we're training 1, 2, 3 because there are 3 network. If they have only 1 network, it's just write 1. So after 3.1.1 is training process, and 3.1.2 is what? It's inference. Inference. Okay. Usually, inference is very similar to the training, except they don't have a loss function. But inference always has a we call post processing, 后处理。inference 有很多是后处理的。For example, this one, right? Inference input, we have 3 networks, and so the output and input, output, input, output. Final output, we have a post process. Here they use non-maximal suppression for post process, but this non-maximal suppression they developed by their own method. 他们自己发明的另外一个 non-maximal suppression 的方法。And then in the paper, they don't tell like this one. 像我学生他这个没讲。How can you do that? So 2 ways. One is if you search the internet, probably some people already study this paper and they write their own way to explain to you. So you can just copy it down here. Or you need to write by yourself. That's meaning they write in content. Can you, based on those content, use figures to represent those content? That's important. 就是说，你如果厉害的话，通常好的 PPT 是把它写的内容用图形方式表示，而是简单图形方式表示。所以这个是学生自己画的，他把那个内容他把它画成这样子。那这是学生画的。那我说这个可以到 Internet 找 paper， 找人家有些很善心人士，他把一些读过的东西放到他的部落格上面，你把它 download 下来没关系。最好是注解一下，不然他会告你。不要被告，你要注解一下这样子。就像你的工作被引用放进去，你会很高兴啊。可他没有把你名字写进来，你会不高兴啊。就这样，人性关系。写一下没关系的。好 ，so this is inference and 3.1.3 this is loss function. So what's the loss function here? 我这里没写了，你要把 loss function 有，它跟会有。这个 loss function 你要把它写进来，这样子。OK。So that is a 3.1. So 3.1 have a 3.1.1 training process. 3.1.2 inference. 3.1.3 loss function. And then 3.2 is the part we did not explain enough. We did not explain clearly. We will explain in 3.2, 3.3, 3.4. OK， 就3.2、3.3、3.4，就是你在这个 framework, for example, support detail we did not explain really clearly. So we will do here. So for example, suppose we are YOLO V4, and then they did not explain clearly. Probably you need to find other paper talk about YOLO V4 here. So we write the details here. 这样子。所以3.2、3.3、3.4都要解释前面解释不够的地方。那至少是这样的要求学生在做这个 PPT。那我在美国那边也是，人家就是研究所几乎都师徒制的，所以会有门派，是哪一派出来的？但是不是真的门派，就是哪一个大师出来，哪个大师这样出来的啊？就有这些，那训练出来会不一样。因为你要跟尤其是博士，你要跟老师相处，可能4、5年、5、6年到7年这样子，一天到晚在一起，所以会受影响。OK， 会受影响。简单来讲，如果老师很会喝酒，你就跟着喝酒，因为你要陪他喝酒。 有很多老师人会喝酒，我是不会喝酒的。我老板很会喝酒，但是他是12点后晚上12点，你美国学生跟他去酒吧里面喝酒，是学生酒吧，美国的学生酒吧，你不要以为酒吧都是那个那种电影看到那种酒吧，不是哦。美国的大学，因为他们是社交的地方，美国大学旁边都有酒吧，那个酒吧叫学生酒吧，很单纯的学生酒吧，因为他们习惯就是去酒吧喝酒聊天，也有老师，也有学生在那边这样子。OK，那我为什么没去？那一开始是太样了，然后功课做不完，不敢去。那美国人做完，他们跟陪老板去，然后我们不敢去。那个 Henry Shaw 很厉害，那个美国我们那个一个大学长大我2届，他那个很快就做到微软的副总裁啊。我看他社交很厉害，他18岁大学毕业的，英文非常好。我去上班有跟同事去酒吧，因为那是社交地方，去看运动聊运动，所以那些球员4个季嘛，那些每个那个区域 football 球员记得 basketball 球员记得 ball 球员记得啊，我们有在 hockey 大概知道一两个这样，这样才办法跟还好我喜欢运动，所以才有办法跟老美混在一起。所以你不要小看那个他们老美有时候从高中就懂这个球员，高中时候是什么球队，高中表现什么，我是大概直到大学，高中我就不晓得。好，所以这是美国的文化。Okay, so this is a 3.2 for example. Okay, so that's for your reference. 这跳过去了。Okay, 3.3 is the other part. We did not explain clearly. 那这个都有，不是乱讲啊。So this one training process, right? So they first classification and bounding box. They explain step by step. So those you should write on the PPT in chapter 3. Chapter 3 talk about the details of the content, actually the method. We want to learn the method. So that's for the chapter 3. And the last one is the experimental result. So that's a chapter 4. So chapter 4 is chapter 4. So chapter 4, 4.1.1 is what? Data collection. 4.1.1，那个助教注意一下，你们看也是看有没有组织好哦。PPT 我会再看一遍，好，那没有组织好，分数就拉下来了。So 4.1.1 data collection. So for example, in their case, there were 2 data. One is the wider face. The second one is for the Denmark. So there were 2 data sets and figures. And they say, okay, 80% total have a lot of images, but in this case, they only use some part of the photo images. And 80% is for training, 10% for validation, the other 10% is for inference. But paper did not tell you this one. Paper just write the number. So sometimes we add some, do a little bit process. 就 paper 没有讲这个，但是没有讲到 percentage， 那我们就把它加进去这样子。然后 4.1.2 is a matrix. Matrix is meaning what kind of equation, what kind of mathematics we try to evaluate the performance. That's called matrix. So matrix usually is a equations. 你用什么数学是在衡量你的 performance 叫 matrix。通常会如果有时候他讲这个 sometimes they tell you this one, they do not write the equation. You should go to the internet to find the equation and write it here. And so that's a 4.1. 4.1.1 is the data collection. 0.2 is a matrix. And then 4.2, 0.3, 0.4 is experimental result. 1 experimental result. 2就是后面4.2、4.3、4.4就是在讲，你第一种研究的结果是什么？ 第二种实验的结果是什么？不是研究。第三种实验的结果是什么？就这样写下来，就分类嘛，写下来。那它这里也有所谓教你写论文跟做 paper。training data 还是这样想，他先讲 training data 嘛，然后评估方式他会讲，但是他有时候只点过。他这里跟你讲他整个 data 比率是什么多少，那再就是他的实验嘛，那实验评估，那不同的实验评估方式这样子。OK， 那 finally is a conclusion or sometimes we write, so there's have a table of the result, this table of result. Finally, we say our conclusion and the future work. So this is the last chapter, talk about this one. And then we write a reference. You just copy, use a snapshot, copy to here, the reference. So that's your report you need to write. And I will check this one. Okay, so this one is the most important one, is that you present, and so sorry, do the presentation, and important one is this one. Okay, and you show people the result. Show us, show TA, show me the result. You said you run your source code, so we want to see your result. But remember, if don't worry about that one. What I mean is that if you download a paper, you have a source code, you run the result doesn't work, it's fine. But you should write why. You should write why it doesn't work, what's the problems, or suppose their performance is 90%, your test result is only 50%. That's also fine, because the purpose I want you to do the project is not the result. Results is your research, your thesis. But in this class, the important one is that I want you to learn how do you do the presentation. The most important one is how do you do the PPT. So I only write 40% is the PPT, but this one will affect your presentation, because your PPT is not good, your presentation doesn't mean will be good. Okay, and your source code, you upload the source code. If your source code is like we say data body, right? 那个尸体嘛，你的尸体 that's actually that's fine. Don't worry too much. But what I say is that, so if your result not good in your experimental result here, you should write, okay, the result, the paper is this one, but my result is not good. Why? I feel why it's not good. Because sometimes like you do the GAN, GAN is not easy to convergent. If you do the research about GAN, it's not easy to convergent. So your result, for example, you say, okay, because my my GPU is only 1080. And I find the result because like homework, the total loss is look like it doesn't convergent. The training data, the validation data is not, the result of the validation is not good, because my GPU is not powerful. So hopefully I can have a H100. That's for example like that. Okay, just write a reason to excuse yourself. Okay. Okay, so that's for the PPT file for the final project. Any question for the final project? It's very important. Okay. So we take a 10 minutes break until 10:15, and we'll go back to teach you the faster RC and